Welcome to this video on the sampling distribution. Welcome to this video about test about a difference in means. By the end of this video, you should be able to state appropriate hypotheses for significance test about a difference between two means and determine whether the conditions are met for performing a test about a difference of two means. So in today's scenario, I have the scenario set up of 30 students took the AP exam last year for me. They were informed later that College Board gave them two forms of the exam, which were randomly assigned to the students, and here's the result. So on Form A, we had some 3s, some 4s, and a whole bunch of 5s. And in Form B, we had a couple 2s, a couple 3s, more 4s, and some 5s, but less 5s in Form A. So to find the mean score for A, I put our data set into my calculator, and I ran one variable stats, and I got a mean of 4.2. The mean score for Form B was 4.0. So now we're going to have a difference, find the difference of the means. These are two independent random samples because we have no crossover between these. A minus B. So we have a difference of means of 0.2. So assuming the two forms are the same difficulty, now that should sound familiar because that's really saying our null hypothesis. So that's really saying mean 1 minus mean 2 will equal 0, assuming that they have the same difficulty. So if Doug scored a 5 on Form A, he would also score a 5 on Form B. In other words, Doug is a 5 no matter which form he is randomly assigned. Okay, so now the 30 AP scores from class, so I did a randomly assign half the class to Form A and half the class to Form B. So they were randomly assigned. And what is the difference in mean score in this random assignment? So our alternative here is that mean 1 minus mean 2 is not 0. So we're going for a two-sided test here. So with this, when I randomly assigned, the mean for A was 4.27 and the mean for B was 3.93. So the difference in the two means was 0.34. All right, so here is our dot plot. Make sure you pause the video so you can copy this down. So up here, this was an example of one difference. I did this 30 times, and then this was our dot plot that resulted from it. So copy this down and come on back. All right, so what this shows, this distribution is the randomization distribution of X bar 1 and X bar 2, because I randomly assigned the cards. So that's where the randomization comes from. And each dot represents one difference in means for one person. Okay, they before and after. Okay, now Etowah last year had a difference of mean scores of 0.2. Is this outcome surprising if we assume both forms are the same difficulty? So let's look at our graph up here. 0.2, this is what Etowah had. So we're always, when we make our statements in our conclusion, we're saying from some point or more extreme. So from 0.2 to more extreme. But if we remember and we go back to our alternative hypothesis right here, remember we had a two-sided test. So we're not just talking 0.2 and greater on one direction. We're also wanting to go 0.2 on the lower side and further out from there. So we'll include that in our data. So 0.2 on the lower side and more extreme. So anybody from these points and more extreme, how unusual is to be in that spot? So when we count them up, we ended up with 17 out of the 30 results were 0.2, had a difference of means of 0.2 or greater. So that is 57% of them. That's our p-value. So really not uncommon at all. So our results were pretty normal. So what I want you to do is I want you to Interpret your p-value here. That's your assuming the null is true statement. And then I want you to make a decision about your null hypothesis and what is your conclusion for the alternative then. So it's taking what we normally do for our conclusion and kind of splitting it between the two. So pause the video, give those a try on your own, and come back to see how you did. Okay, so was our outcome surprising if we assumed both forms had the same difficulty? No, our outcome was not very surprising. Assuming the two forms have the same difficulty, there is a 0.57 probability of getting a difference of means of 0.20 or greater, and that's in either direction, purely by chance. Okay, so not very unusual at all. It happens more than half the time. So my decision on that is because our 0.57 is greater than alpha, we're going to fail to reject the null. And when we fail to reject the null, that means we do not have convincing evidence that the forms, that one form of the exam is harder. Okay, so there is no convincing evidence to say that Form A was harder than Form B or easier than Form B. There's nothing here to suggest that at all. So let's go ahead and flip this over and summarize our lesson for today. All right, there's a couple things that I want to review real quick. Very similar to when we did significance test for proportions, how we write our hypotheses are very, very similar when we're talking about a difference of mean. So for our null, we can write mu1 minus mu2 is equal to 0, because your null is always the equal to 1. You could also write, that also means the same thing if mu1 equals mu2, whichever one you prefer. They mean the same exact thing. So that's for our null. For our alternative hypothesis, we will have either mu1 minus mu2 is less than 0, and that means that mu1 is less than mu2. We could have that mu1 minus mu2 is greater than 0. That would mean that mu1 is greater than mu2. Or we could also have, like we did on the front, mu1 minus mu2 just doesn't equal 0, meaning mu1 is not the same as mu2. When you're defining your parameter, you need to be sure to state your direction of subtraction. So be sure to define your parameter. mu1 minus mu2 with your subtraction order. So I want to know the order you're subtracting in. If they tell you the order, make sure you subtract in that order. If they do not tell you the order, you're stating and letting your reader know the order that you're picking. It doesn't really matter if they haven't told you. When you do your check your understanding here, it's based off of the data on the front. And on the front, they took Form A minus Form B. So you want to be sure to state that in your parameter when you define it. Now the other thing I wanted to talk about is to remind you about our conditions. All right, of course we're going to start with random, and we will either have a random sample. If you have a random sample, that means you can generalize to the population. Or you can have a random assignment. If you have a random assignment, that means you're looking to show causation. All right, our 10%. So you only when you're sampling without replacement, only use when sampling without replacement. That's so we can use our standard deviation. Okay. Otherwise, you want to note the sample size 1, and that is less than or equal to 1/10 of the population of 1. And sample size 2 is less than or equal to 1/10 of the population of 2. Got to include both of them. And the third part that you want to look at is your normal large samples. And just like before, we have 3 conditions that could make this happen. The first one is both. That's real important. Both populations are approximately normal. Or sample 1 is greater than or equal to 30 and sample 2 is greater than or equal to 30. So you can use the central limit theorem. Or our last choice, both sets of data show no strong skew or outliers. All right, for your check your understanding, it goes through the scenario from the front, and really they want you to write the, do the state and the plan. You've already kind of done the do on the front. On your plan, I have 30 students and I assigned half into each group, so I have 2 groups of 15. My sample sizes are not big enough. We don't know anything about the population, so you're going to have to examine the data. And the data comes from right here. This is the data that it's referring back to that we got the information from. All right, I hope that was helpful. Let me know if you have any questions. Check your answers on the key. See you in class.